Hello and welcome to Easy Maths. In this video, we're going to focus our attention on the area of inverse of a matrix as we continue in our series of lessons on the topic of matrices. And as always, please like, share, and subscribe. I'll appreciate, and you'll also be able to access more of the content I've developed. Let's turn now to the inverse of a matrix. We are only going to be dealing with the inverse of a 2 by 2 matrix, and therefore, let's begin by saying that given the matrix M, which is A, B, C, D, then the inverse of M, which is normally written as M raised to a -1, is normally given by this particular formula here, which is 1 over determinant times the matrix reversed or interchanged in some way. And I'll explain that. Det, I'll say the determinant, which is the determinant, which is just the product of the elements leading diagonal minus the product of the other elements, B and C. And we said that in the previous lesson. However, for this particular part here, these are the elements that we had for M up here. However, something has happened to them. A and D are interchanged. A and D are interchanged, so that they look like this, D and A. The signs for B and C are reversed. Here we had C and B being positive, and so here they are both negative. So the signs have been reversed. Notice that if they were negative here, we would have them positive. Or whichever element that is positive becomes negative, whichever element is negative becomes positive. Now with that, maybe we should go to an example, and we have a question here. We have the matrix 2, 1, 4, 5. We are to determine the inverse of this particular matrix. We first of all need to determine the determinant, which is the product of the elements, the leading diagonal minus the product of the other elements. That is 2 times 5 minus 4 times 1, which gives us 6. The inverse, therefore, will be the reciprocal of that particular determinant times the matrix transposed, and transposition means doing what we said in these two notes here. The 2 and 5 are interchanged, so that you have 5 and 2. The signs for 1 and 4 are reversed, so that we have -1 and -4. And this one is simplified to get the matrix that you have before us here, which is the inverse of the matrix 2, 1, 4, 5. Now, please notice that when we have this particular inverse here, we can pre-multiply the matrices like this, or just multiply them in any particular way, either this way or the other way here, and the answer will always give us the identity of a matrix. Please notice that the concept of identity, determinant, and inverse of a matrix are normally used together because of how they help out in solving simultaneous equations, and shall see that in other lessons in the future. Now, please notice that generally for any matrix M, M times its inverse should be equal to the inverse times M should also be equal to the identity of a matrix. And this is the same statement that has been said earlier here. Again, notice that if the determinant of a matrix is 0, then the matrix has no inverse, because we would have 1 over 0, and 1 divided by 0 is ambiguous or unknown or undefined. And therefore that particular matrix would have no inverse if the determinant was 0. Maybe move on to another example, example 2, where we have the matrix 4, 3, -2, 6. The determinant is obviously 4 times 6 minus -2 times 3, which is 30. And therefore the inverse will be the reciprocal of 30 times the transposed matrix. So interchange 6 and 4, reverse the signs for -2 and 3, so that I have 6 and 4, but 2 -3, following these two rules that I explained earlier when I was introducing the lesson there. And therefore this would give us a matrix we have before us here, which can be simplified to a fifth minus a tenth minus 1 over 15 and 2 over 15. And that brings me to the end of that particular lesson on the introduction or definition of inverse of a matrix. Please check out for the video which has to do with examples of the same area. Thank you.